Hi, welcome students to another video lesson about quadratic equations. Let's start with the definition. In mathematics, a quadratic equation is a polynomial equation of the second degree. The general form is ax squared plus bx plus c equals 0. This is called a general form. Here, x is a variable, or we can call it unknown. A, B, C are constants. A is not equal to 0. Because if A equals to 0, then this equation cannot be quadratic. The constants A, B, and C are called respectively the quadratic coefficients of variables. This polynomial has a degree 2. That is, ax squared plus bx plus c is a quadratic equation. Here we can have an example. 5x squared minus 3x plus 3 equals 0. This makes it quadratic. The x squared makes it quadratic. This word quadratic comes from quad, means square, because the variable x gets squared. It is also called an equation of degree 2 because of the 2 on the x. Now, how can we find roots of this equation? A real number a is called a root of the quadratic equation. If a is a root of this equation, then we say that a satisfies the equation. Like when we put a substitute value of an a into the equation, we get 0 in the end. Or x is a solution. X equals a is a solution of the equation. The root of a quadratic equation are called zeros. We can call it roots, or we can call it zeros of the polynomial. Another examples for this equation, for example, 2x squared plus 5x plus 3 equals 0. Here we can see a is 2, b is 5, and c is 3. And what if it will be like x squared minus 3x equals 0 and there is no c, there is no number without variable? This one is tricky. Where is a? A is equal to 1, as we don't usually write 1x squared. And c is 0. It's not shown here. What if 5x minus 3 equals 0? We cannot see here any x squared. That's why we cannot call it quadratic equation. So this one is just a linear equation because the x is not getting squared. Now we have seen the standard form of a quadratic equation, like this. But sometimes a quadratic equation doesn't look like that. Here we can see some examples below in the table of different form. We can see x squared equals 3x minus 1. We can move all terms to left-hand side and get a standard form, x squared minus 3x plus 1 equals 0. Just like this, 2 multiplied by the difference of omega squared minus 2 omega equals 5. And now here we can expand brackets and move 5 to the left. These are all called quadratic equations, just given in a slight different form to us. There are 3 ways to find the solution. Usually we say only about quadratic formula, that's called standard formula, or we can factorize the quadratic. Sometimes we also, but here I added that we can complete the square. This formula is called quadratic or standard formula, which is x equals to negative b plus minus square root of b squared minus 4ac over 2a. This says the quadratic equation can have 2 roots with plus sign in between b and the square root and negative sign. This is called discriminant. The expression b squared minus 4ac in the formula is called the discriminant because it can discriminate. We have three cases. When discriminant is positive, that means it's greater than 0, we get two real solutions and not equal solutions, not equal roots. When discriminant equals 0, we get just one real solution. Or both answers are the same or equal roots. Equal roots. And when discriminant is less than 0, that is negative number, we get no real roots. Or we can call it imaginary roots, as we can write it as a complex number with I. This is an example of using the quadratic formula, standard formula, for 5x squared plus 6x plus 1 equals 0. Here we can find immediately a discriminant, which is equals to 16. 36 minus 20 under the root, square root, gives 4. So we can find two roots by the formula, which is negative 0.2 and negative 1. Another way is factorizing quadratics. It's called factoring because we find the factors. A factor is something we multiply by. For example, x squared plus 3x minus 4. This equation is multiplication of two brackets, of two terms, which are x plus 4 and x minus 1. When we multiply these two terms, we get the full quadratic equation that is given. Multiplying x plus 4 by x minus 1 together is called expanding. In fact, expanding and factoring are opposites. We can expand brackets or we can factor the equation. This is the algorithm for factoring the equation. First we set the equation equal to 0. Then we factor. The factors will be linear expressions. Set each linear factor equal to 0 and then solve both linear equations, which is very simple. For example, x squared plus 3x equals to 0. We can factor this equation as x multiplied by the sum of x and 3 equals to 0. Here, after this, we can equate both of them to 0, which are x equals to 0 and x plus 3 equals to 0. So we found two real roots, which are 0 and negative 3. Sometimes the equations can be given us as in incomplete form, so we can complete the square. For instance, in this example, x squared plus 4x plus 1 equals to 0. They moved the number term to the right side of the equation as x squared plus 4x equals to negative 1, and just added positive 4 to both sides. That changes nothing. They did it just so that we get the square of a sum, x plus 2. This gives us x plus 2 squared. And now we can easily equate these two terms, x plus 2 equals 3. And let's start with this example, x squared minus 49 equals to 0. We can factorize this into two terms by short multiplication formulas. The first one, x minus 7, x plus 7 equals to 0. And then we can equate these two terms to 0, such as x plus 7 equals to 0 and x minus 7 equals to 0. And then we find the unknown variable x, which are negative 7 and positive 7. Let's consider another problem. 3x squared minus 75 equals to 0. we can notice that there is no b from the general form, and there is no perfect squares. We can take out the GCF, great common factor, out of the brackets, which is 3x, or 3, and then it will be x squared minus 25, as 75 divided by 3 is 25, equals to 0. And now we have perfect square. 25 is a perfect square, as a square root of 25 is 5. So it's going to be x plus 5 and x minus 5. Then we equate these two terms to 0, and the roots will be positive 5 and negative 5. The next example will be 9x squared minus 64 equals to 0. Now this is perfect square. 3 squared is 9 and 8 squared is 64. So we can factorize this into two factors, which will be 3x plus 8 and 3x minus 8. Very easy. And then we're equating the terms to x and finding the unknown variable. Will be negative 8 over 3 and positive 8 over 3. What about x squared minus 2x minus 15 equals to 0? We don't write 1 in front of the x squared, but we know that a equals to 1 and c is negative 15. We can factorize negative 15 so that we can get negative 2. When we add negative 5 and 3, we get negative 2. So that's why the roots will be negative 5 and 3. We can factorize it as x minus 5, x plus 3, and equating it to 0. X will be 5 and negative 3, two real roots. The next one will be, the next example is x squared plus 3x minus 28 equals to 0. Again, we're factorizing the c number, negative 28, so that we can get positive 3 when we're adding factors of negative 28. Factors of negative 28 will be negative 1 and 28, right? Or 2 and 14. But we don't need them. 4 and negative 7. Or maybe negative 4 plus 7 will be positive 3. So we need negative 4 and 7. X minus 4 and x plus 7. The roots will be 4 and negative 7. Next one is 8x squared plus 2x minus 15. The solutions are given 5 and negative 3, and we should prove that the roots will be 5 and negative 3. Here we are using standard formula, discriminant, square root of b squared minus 4ac. A is 1, b is negative 2, and c is negative 15. Negative 15 is c, and now we're substituting into the formula. Discriminant is b squared, that is 4. Negative 2 squared is 4. 4 minus 4 times 1 times negative 15 will give us 4 plus 60. It's 64. Square root of 64 is 8. This is the perfect square. And 2 plus 64 will be, no, 2 plus 8 will be 10. divided by 2 is 5. The first root is 5, and 2 minus 8 will be negative 6 over 2 will be negative 3.